Thanks very much, Ross. Pleasure to be here with you guys this morning. I wanted to dive deeper into the API story and kind of put a wrapper around it and give you some recipes for how you can succeed in this new economy. I think the critical observation is that APIs are no longer some project that runs in the back room in some IT server closet. APIs have come to the forefront. APIs are now in the bright daylight. And APIs are really powering your business. There's something that's very, very visible. There's something that has become critical to a lot of your business initiatives. And to that extent, these APIs are kind of popping up everywhere, right? They're something that the rest of the business is starting to actually recognize. And as we just saw right here, there's a frame of mind that helps you succeed in this API economy, or at least think about it properly, and that is to truly think about an API as a product, not as an IT initiative, not as some technology that powers something, but really as a product on its own. And once you start thinking about the API as a product, you start to realize that it actually has a lot in common with other products that you're thinking about, right? So an API will actually have a budget, or an API initiative actually has a budget. So there's something to actually power it through. And an API has momentum, right? So it has a certain time by which it actually has to get somewhere. It has people who are driving for it. It's got internal support. It's got business support. It may actually have some P&L associated with it. And to that extent, it's also extremely visible, right? It's something that you can fail on as well as succeed on. And it's something that has hard timelines that you actually have to meet. So just like any other product, it's got its strong positives, right? And it's got its areas of risk. And so how do you actually thrive in this API economy when you have to get really good at this kind of stuff? And the way to thrive in the API economy is by realizing that because the API is actually a product, you have to treat it as great product companies do. And this includes also your existing APIs, right? So this isn't just for new APIs. If you've got APIs there's a lot of things you can do by thinking about them like great product companies think about APIs. And so great product companies start from the consumer of that product, right? They start from the actual audience. You understand who the audience is for this API, and then you work backwards from there. So you identify those audiences, and then working backwards, you think about, how am I going to package this product? How do I package this API? Right? How do I progressively reveal the capabilities of this API? What kind of experiences this API can end up creating for you? And thinking very carefully about what the actual consumer of this product actually needs. How do I empower that consumer? How do I make sure that that consumer's experience from beginning to end is as successful as it can possibly be? So the first thing you want to do, just like with any other product, is you want to make sure that it's discoverable. You want to have some place, some catalog, some obvious property where you can list your products, where you can list your APIs, and other people can discover it there in a variety of ways. And it's a well-known place where APIs go to live, and so people who are looking for APIs or looking for capabilities can go and search in there. And it has to be such that this catalog adds a lot of value. It can't just be an entry somewhere. It actually has to add a lot of value to the people who are searching and then consuming that API. Right? So, for example, it has to be extremely easy to add a new API to this catalog. Right? And you have to be able to create a new portal, a new developer portal, in which you can discover more information about that API. That should be a single-click kind of process. And inside that portal, you have to be able to provide a lot of information, how to get started with this thing, what is the value that this thing actually presents. The first thing that people look for is documentation. That documentation should be very rich and should be as automatically generated as possible. And make sure that that documentation has a lot of examples in it, right? Because the actual user of this portal is the developer. And the first thing developers look for is examples, right? They don't really love to read documentation. They expect that it's there for them, but they love to actually see examples. That's how developers think about things. Now, one of the most important things to think about is how do they actually get started, right? What are the steps necessary to actually get started using this API? How do I enable that? And that goes along the mantra of self-service. So they shouldn't have to go and ask someone. They should be able to get started on their own as quickly as possible, lowering that barrier to entry. And thinking about all of these aspects, we've kind of come up with a name for that. just like the API is the application programming interface. So we call that the application programming experience, right? The APX, the owning it from the beginning to end, whole experience of actually consuming this API. And so give them a quick start guide. Show them how to actually request access, and ideally make that access granting automatic. And we'll see how we can actually do that inside the Anypoint platform. So they can get started really quickly. The sandboxes and the data is already there, and the authentication credentials are already given to them. And then the next thing is, well, do it again and again and again. This shouldn't be a one-time heroic process, right? This should be the kind of thing that every API is treated like, right? You should think about every API, whether it's internal or external, as a product that's actually externalizable, something that you would be proud to put in front of your customers. And if you do this and you get really good at it, then it turns out that your internal projects as well as your external projects are a lot more successful. It becomes part of your institutional muscle memory, right? You get really good at this kind of thing. You do it over and over again. Set yourself up for this kind of pattern. Okay, now, there's one thing actually missing in this whole story that we've talked about, and that's the API specification. Because just as an API is a product, an API is also a commitment. You're asking people to build their applications on top of your API, which means there's a contract there. You're telling people what you're going to provide, and you're telling people what they can depend on. So there needs to be some way to actually specify that contract. The API is a contract. What mechanism do you use to actually specify that contract? And just as you wouldn't do business with a partner without a contract, you shouldn't actually publish an API without a spec. So how is this actually done today? Well, one of the common ways is through documentation, right? People just say, look, I just documented my entire API. There's a problem with that, right? Documentation is necessary, but documentation isn't sufficient to specify an API. Let's say that I go tomorrow and I get another doc writer to go and document more of that API. Has the API changed? Has it not changed? Right? It's very hard to build applications on something that only exists in documentation. Documentation is just too loose of a way to specify what an API is. So what developers will often do is they say, no problem, I'll actually build my API into my implementation. I'll go into my code and add little pieces to it, and the API spec will actually just emerge, right? Whatever it is I've implemented, by definition, that's the API. Well, that's not much of a contract. It directly links your implementation to your interface, right? Which means that if you go in and you make what you think is just a bug fix, maybe you've changed the contract, maybe you've changed the interface. You don't know because there was never actually any solidified contract to represent that API. Well, so what we need is, right, some kind of source code for the API. Something that actually embodies the interface itself, not the implementation. Something you can check into your source-controlled system so you know exactly when it changes. And ideally, that thing that you check in is readable. And the reason it's readable is the same reason that why a contract is readable. So you can actually tell what your commitment is. So your developers know exactly what it is that you're going to be delivering to them. So what is that readable source code of an API? Well, if you're doing SOAP-based APIs, which is the traditional older way to do things, then that contract is the WSDL, a web services definition language that describes for you exactly the surface area, if you like, of your interface, right? And all the tooling stacks are all built against WSDL, and this is a well-known thing, so that's a solved problem. But increasingly, more and more people are actually doing RESTful services. And for RESTful services, what should you use as your specification? There are a few options out there. What we would recommend and what we've centralized our solution around is a newer platform that we and a few other people, or a newer spec language that we and a few other companies introduced last year, and that's called Raml. So Raml is the RESTful API modeling language. It's about a year old. We actually introduced it at a similar conference just about a year ago. And the way that we did this is we went back and we said, you know, how do we introduce something that's as simple and clear and as addictive, frankly, as REST itself in order to specify RESTful APIs. And we did that along with a group of other people who had the same kinds of things in mind, either companies that are providers of solutions like us or companies that have been thinking about APIs and living the pain of more RESTful modern APIs for a long time. And so putting this open work group together, Raml was released a year ago, and it's been doing really, really well. We've standardized our offerings around this, And I want to introduce some of the aspects of this right here. Okay, so with that in mind, here's what Raml actually looks like, right? It's not some horrible thing that's behind the scenes that only advanced developers should look at. When you look at it, it actually looks very, very simple. It just tells you exactly what are the moving pieces of your API. It's designed to be highly readable. It's designed to be something that you would get attached to just as you've gotten attached to the simplicity of REST. And not only is it designed to be highly readable, it's designed to be highly writable. And that's actually really important, because if you feel very comfortable writing and tweaking and changing your API, then you're probably going to be successful at intentionally designing your API. And that's really important. You should design your products for the purpose that they're supposed to fit, and not just end up with whatever product people happen to build for you, right? So design is something that's enabled by a very clean API specification language like Raml. Now, some of the things that you get out of this is tooling that generates all the other artifacts that you need in order to make your API initiative successful. So once you've specified the Raml, literally as you type your API specification in, an API console forms to the right to show you exactly what kind of documentation your developers are going to end up with this particular specification, right? Now, you get the full-on documentation, nicely formatted, something that you can present, but you also get a live console that allows you to actually make calls into that API and see exactly what those calls are going to look like. So it essentially generates a form for you that's specific to your API, so you can see how to interact with this thing. And it does it by creating a mocking service behind the scenes that acts exactly like your final API will actually act based upon your description. It adjusts itself as you type in that API. Okay, now there's one other thing that you need to do in order to verify that this API that you've designed is actually going to work. Not just make individual calls, but actually script out entire use cases, right? Rare is the API that has one call that you make, you get back your information, and you're done. Usually you want to make several calls and, in fact, mash it up with other APIs into the full-on use cases. How do you know that your API will actually work in that case? Well, we created this tool called the API Notebook that you can point it at a Raml file. And as soon as you point it at the Raml file, it instantly gives you a little client that you can start scripting out your use cases. Make a call here, get the information back, make another call. And as you discover your use case and verify your use case, it forms a document that you can share with other people, and they can play the same thing. And again, it makes calls to your API. So you start to generate use case documentation around your API. And one of the most interesting things is you can give that to your users, to your developers, and they too can start making sure that their use cases will work, share it back with you, and you start to understand how are people actually using my API, which is one of the hardest things as an API provider to actually understand. When all you're seeing are the calls coming in, how do you know what it's actually being used for? API notebooks are a wonderful way to do that. And all of this stuff is generated automatically once you've actually specified the API in Raml. Okay, now, you've got your API designed, you've validated that it's actually going to work, or maybe it's an existing API and you've created all of the tooling for people to go and consume it. But how do you know that when you actually launch it, it's actually going to work for you? Is it really ready for prime time? And we've got very large customers who have done an internal sweep to see all of their internal APIs. Are they really ready? And what they found out is many of them actually not. They may have been used internally by a group or two. They may have already cobwebs growing on them. How do you make sure that those APIs, even your existing ones, are actually going to work? Well, a really important way to do that is to use an API gateway. So the API gateway is something that goes on top of your API that helps make sure that only the right people have access to that API, that helps protect the systems behind the scenes from getting too much traffic, from getting hammered and going down as a result of that, and really helps you put a service layer or an intermediate layer right on top of your API to protect both access and traffic shaping on top of that API. Now, as soon as you put the gateway on there, you want to be able to configure that gateway and go and make various changes to it, right? So here's the kinds of things you should be able to do. Very first thing is you should be able to create that gateway really instantly, right? It should really be a one-click press of a button, and that gateway is going on there. And as soon as you deploy that gateway, you can start to configure it with things like access policies. So here's a list of access policies. You can see a few of them up there. For example, there's some traffic shaping policies to protect the systems behind the API, rate limiting and throttling and so on. Right? There's access control mechanisms in here, right? HTTP basic authentication, you can blacklist or whitelist IPs. There's a whole series of these. And then there's integrations with your existing identity management system. And that has both the protective capabilities to make sure that only people that you say can access your APIs, but also the single sign-on enablement capabilities to allow your developers to get onto these APIs as quickly as possible. Right? So you can actually request access and again set up the system such that the access is granted automatically if that makes sense for your particular use case. And on top of that, actually create SLA tiers to make sure that different application developers get the kind of quality of service that they're entitled to get. So all of that is possible through the API gateway, which can be deployed on-premise or in the cloud, wherever it actually makes sense for you. And now your API should be a lot better for actual real prime-time deployment. Okay, so that's great for a single API, but the one thing that we know as constant is change. No matter what you do, you're going to need to change that API into something else. You may want to enhance that API, you may want to change it to something else. How do you remain agile with these APIs? Well, let's take a look at one approach to doing this. The key to remaining agile with APIs is to make sure that that ability to version APIs is actually built into your platform. So creating a new version should be a matter of just point and click, right? That the thinking of what it takes to version an API shouldn't be something that you put in afterwards. It should be something that's already thought into your platform. You should be able to just click here, give it a new version, and take your existing API and continuously evolve it into the next version of that API, right? So take a look at that and enhance it into the new capabilities that you want, right? Now you can do that at completely design time without actually changing the API implementation. And then once you've realized that your new version is actually going to work for you, just like we saw before, you want to actually implement that change. And you want to do that on a platform that gives you the new capabilities in as easy a way as possible, right? So in this case, we've got a flow that says if I'm going to my old version, it's going to go where it was before. And if I'm going to my new version, I've got all the connectivity capabilities of the Anypoint platform to enhance that API to meet the new requirements, right? Again, point and click with visual tools that you can assemble really, really quickly. And that gives you the ability to go version after version and get really good at deploying these APIs, which brings us to our target state, right? Your target state is when you can do this thing over and over and over again to meet changing business needs. So the target state is what I call sort of a Zen state of smart connectivity, right? And it's got these two pieces to it. It's got the ability to design APIs purposefully for the reason that you're actually doing those APIs. And then it's got an ability to go and implement those APIs in a repeatable way without writing lots and lots of custom code. Because this stuff keeps going faster and faster. You have more and more of these APIs to do, and you really have to get really good at this kind of stuff. Let's look at those two pieces individually. This becomes sort of your new mechanism of operating in this agile, very fast-moving world. So the first part of this thing is the Agile API lifecycle, all right, where you're going to go through a design lifecycle, much like you do it for user interfaces, you're going to do here for programmatic interfaces, right? So you're going to be designing those APIs through the API designer. Then you'll be mocking them without having to implement anything. You just turn on a mocking service, and now you know whether those APIs actually work. You publish that out to a small group of beta developers. They'll tell you, yeah, it seems to be working, or no, you need to make some changes to this thing. They work through use cases. They read the documentation, and they tell you, you know what? Not quite there. You need to add some paging capabilities, right? You need to change something about the IDs so that they don't conflict with our internal IDs. Whatever kind of feedback you have, you just take them through that process again. This can be done really fast. This is sometimes done in hours, right? So you get the feedback really quickly. You iterate on this thing until finally you've nailed it. And the way that you know that you've nailed it is you publish an API spec, right? On top of that API spec, then you actually build the implementation. And the cool thing is that you can implement the clients and the servers at the same time because you actually know where you're going to meet at the end of that. So you can take that spec, automatically implement it on the backside, connect to all the systems that you need to connect to on the backside with no custom code, while the people who are consuming this can already start building the applications that consume this, for example, mobile applications. That's kind of your 1-2 punch. All right, and with that in mind, we're actually going to do all of this right here in front of you live. And to do that, let me invite to the stage Reza Shafi, who's our Senior Director for all our API products. Please give him a warm welcome. Thank you, Reza. Now, this is going to be interesting. So we're going to design and build an entire application that puts together APIs, integration, and the Internet of Things. In fact, things that have arms and legs. So let's hope that this actually all works together, because we're actually going to do it all live in front of you here. All right, so the scenario that we're going to build here is the following. And again, it's within the context of the connected company and healthcare, and specifically the connected hospital. And it's based upon the following really interesting observation. So in this observation, it turns out that for certain children, specifically autistic children, they have a really hard time communicating with adults or even other children, but they have a much easier time communicating with inanimate or semi-animate objects, robots specifically. And so people are starting to actually use robots to communicate with these kids, to treat these kids. And so what we're going to do here, if everything is working, is actually build an application that allows the following. It allows doctors or clinicians to interact with these kids through these robots by creating an API on top of an application that then various developers can build mobile applications to talk to that API. And that mobile application will send messages to that API. Inside of the application, we've used DevKit to actually build a connector to talk to those robots. And so it will send the appropriate message to the robots. And the clinician can also record the reaction of the child and, again, submit it to that same API and goes into a medical record that we're starting to build over that child. Now, there are a lot of moving pieces to actually get this to work. Let's see if it actually does. Take it away, Reza.
All right. Thanks, Uri. What we're going to do is we're going to start with the design aspect of the API. What I've got here is the real thing. It's the endpoint platform for APIs. And I'm going to begin with, by the way, this dashboard here is what an API owner would use to address all of the different aspects of the API lifecycle. And the first aspect of the API lifecycle that I'm going to address here is going to be API design. So by clicking over here on the Raml pane here, you'll get into the API designer. And as you can see here, this is the ability to design, to define that experience the right way, as Uri was going over. And you can see here that I have, for the diagnostics API that Uri was just describing, the resources that this API consists of. So you have a collection of cases, and then you have underneath each, for each collection a case ID, or for each case a case ID. And for each case, you can actually perform a set of tests, as well as update the results. And underneath each of these resources, you can see the set of operations that you can actually perform. So for a particular test, or for the collection of tests, I can actually post a test. So I can create a brand new test. And as you've noticed, on the right side here, as you design this API, the interactive console is formed. And what you can do is actually see and browse what is effectively becomes the developer's documentation for this API. You can see that, for example, for tests, we have this particular request type, this response type, and you know what? If this API existed, you could actually try it. Now, remember, Uri talked about the mocking service, and this is a really powerful capability. This is the ability to actually take this API and make it come alive without really going and doing all the work required with this implementation, just to test it out. And so here, at the click of a button, I can press the mocking service, and you'll notice it just created a base URI for me. And this is a live URI. People can go to this URI and actually use it. And just to show you guys how that works, I can now go to the try it button here. I already have a pre-filled example. I could have pre-filled it from the Raml, and I can try this out. So at this point, it's just making a call to the mocking service, and it's returning this response to me. So this API is alive without me having done any implementation. Now, I can do this iteratively and get to the right design, the right APX, and when I'm done, I can actually go and invest in these implementations. The way you would implement it, you would export the Raml, and you can import it into Anypoint Studio, the Anypoint IDE that Stephen was going through earlier on. And you can see here we have the same API in the Eclipse-based IDE. And what Anypoint Studio does is that it actually auto-generates the mock implementation for it so that you have a starting point that the developer can actually interact with right here in the IDE, and then actually evolve with real implementation. So for this API, the real implementation happens to be for our tests. As the tests come in, they actually get sent to the robots. So what we did is we've taken the request comes in from a REST-based API, and you can see here data mapper is transforming the JSON objects to robot commands. Now, how do those robot commands actually get sent to the robots? Well, we have Anypoint connector that we built here for the robots specifically. So you can see here the connector for the robots. And you'll see that what we're doing is we're using the scatter gather, which is it sends asynchronously all of the data to these two different connectors. So both of these robots were actually performing at the same time. And also, we are using the Epic connector that we saw from the earlier demo to actually update the medical records in terms of seeing how things are happening, right? So all of this is going to be actually executed right in front of you. So with that, I'll pass it back to Uri.
All right, awesome. So the other thing that Reza did is he actually built this application and deployed it to Cloud Hub. So just to make sure that we have all the possible moving pieces in place, we've got Cloud Hub, we've got Bluetooth connectivity to these robots, we've got the integration in the middle and the API. And so the next thing to do is to make sure that before we actually open that API to all the developers of the world to start playing around with our robots, that we protect it. We make sure that only certain people have access to that API, and we don't overwhelm these little guys with too much traffic.
We certainly don't want everyone to be able to send commands to these robots. And so what we've done is we're using the management part of the API lifecycle here. You can see that this API is actually being managed on our Cloud Hub-based API gateway here. And so what that means is that we can manage what applications can access this API. In this case, we have a single application that's registered. You can see the SLA tier that is registered with. It's the free SLA tier, and that's automatically approved. We can see the policies that are available for me to actually apply to this API. So you've got rate limiting policies, security policies, as well as OAuth policies that are available here for you to use. And then you can also just define those SLA tiers. Now, along with this, the fact that all of the requests are going through the gateway brings me analytics, right? I get analytics for free. I can see here, for example, this is our overall analytics dashboard, and you can drill into specific APIs. What's going on in my system, requests that have been happening over the last 3 hours in this case. You can see that there's requests from the UK as well as from the US. In this case, you can actually see what's going on in terms of requests by application and platform. So, for example, in here, this is an Android device, and if I just wanted to select this, I can see that all of the calls are from the Acme Hospital application coming in mostly, actually all of them from the UK. So that's the management part.
Awesome. So now, with the API actually ready for external consumption, it's time to open this up to developers, create a developer portal, invite them to come in and actually talk to these robots that have been waiting patiently for someone to talk to them.
So last phase of the API lifecycle here. I'm ready to publish this API and make it available for prime time so that application developers can come in and easily develop applications on it. How do I create those API portals? Where you can see this is the lifecycle here, the last stage of the lifecycle. I can very easily publish an API portal. I can add just general content here around the APIs, code samples, and so on. The API reference documentation, well, that's automatically created for me because the reference documentation is effectively the console, the Raml has all the information needed for me to actually create the right API reference documentation. Furthermore, we can create notebooks that actually interact with this API and show you how it can be used. So as an application developer wanting to write those mobile apps that control these robots, I could just say, okay, show me how I could use this API. And in this case, we have a martial arts test that actually interacts with these APIs. Now, before I actually go into that more, this is just the administrator's view of this portal. You have the front-end view of this portal, and this has been highly customized. Right here, you can actually customize this. And as you can see, this is what the developers will see, and they can actually request access to actually use this API using one of the SLA tiers that we define, and go on from there. So with that, a developer could come into this portal and see this notebook and actually start to play it to see if this API works. So shall we try the martial arts test?
We better.
Let's do it. Great.
All right.
That's good.
Very good.
All right, I think it's really important to understand what just happened here, right? The developer went to the application, to the API portal here, browsed the API documentation, and then saw the notebook, looked at the notebook and said, this is how I interact with this API, executed the notebook. As soon as notebook executed, it acted as a client to the API that's exposed at the access point on the endpoint API gateway. At that point, we're collecting analytics, making sure the security is right. The calls are then routed to the Cloud Hub-based API implementation. At that point, we routed the calls the right way because of API Kit, and the calls were going asynchronously to both robots through our connectors that we built for these robots. We're talking Bluetooth to these robots, as well as recording all of that data in the Epic system. So I think that's worth a celebration.
Let's go celebrate with these robots.
All right. I think what we're going to do is ask these robots to celebrate using a notebook. So let's do that.
Open Gangnam Style. Gangnam Style. 낮에는 따사로운 인간적인 여자. 커피 한 잔에 여유를 아는 품격 있는
Excited robots. Thank you, everyone.